Hey everybody, welcome to our 14th lecture, of course occurring here online. This actually will be the final lecture given to you, as next week we will be doing our final exam. Next week the test will, and I will send an email regarding this, but the test will be similar to the second test you took. You will be allowed to use notes and resources for the test. However, it will be timed, so you do have limited time. So make sure you keep that in mind. Some students think they can just look everything up through resources, but being it's timed, you need to study. That's the best recommendation I can give you, but you will have access due to our situation of online teaching and learning. I am granting access for you to use resources if needed for your final exam. That will be given next Monday on May 11th at just like last time, around 6:10, 6 o'clock. I will email the testing code, access code, and then you can take the test online. And that will be on the last lectures we've done from the last test to and including this upcoming lecture I'm about to do right now for you. Your final Lab 3 is due May 11th as well, as you already should know. If you have any issues with it, please, again, shoot me an email. We can set up a Zoom session this week if necessary. You do need to set up Zoom sessions by Friday. The last day I can do a Zoom session is Friday. So you want to make sure you give me a day notice, and when you pick a time, we can do that if you need help. But you will have to take care of that before the weekend. If anyone else has any other concerns or problems, obviously send me a quick email, and I will get right back to you. Again, I'm checking email at least 2-3 times a day, considering that we've been dealing with this online situation for the rest of the semester. But email me if you have any questions or any concerns, and I'll try to help you as best I can. So lab due next Monday, the 11th. Test at 6 o'clock, essentially. I'll send you the access code. And that's it. So we're going to jump right into the lecture for today. 2 more final topics that we're going to cover. And let's get into it. All right, so today's lecture is Piano Techniques for Recording and Studio Mastering. So we're going to start with piano techniques for recording. So first of all, there are several methods in recording. I put grand piano because that's what we have in the studio, and there are upright pianos I'm sure you're all familiar with that may have some modifications to these techniques, but kind of similar choices. Methods are combined a lot as well, depending on the tonality you're trying to get of your piano and the space that you're in. Today we're just going to look at 2 conventional methods, and again, this would have been done for you in the studio. We would have recorded together some nice piano, but unfortunately we're in these conditions. So I've pulled some video that can demonstrate actually pretty close to what we would have done in the studio with these two methods. We actually probably would have combined a method or shown you a third method, but I want to keep this again relatively simple because we have this distance learning. So these are probably 2 of the biggest techniques used in recording piano, and I put some video that I'll show you shortly. So let's take a look at our first method. Our first method is known as XY coincidental miking. XY is used in a lot of applications. If you actually look at some microphones on some video cameras and equipment actually in the consumer market, you're going to find XY patterns around. And what an XY pattern, or coincidental miking we call it, means, and you're going to see in a second when I show you pull up the video, the microphones are placed 90 degrees, sort of 90 degrees axis. Think of an XY axis like in algebra, and how you have the X and Y are 90 degrees essentially. The microphones are placed in that pattern, and what that allows for is sort of a stereo image. There's actually a classic stereo image captured, but what's really nice about it is it minimizes any chances of phase cancellation. And you should remember from COMM216, hopefully, and a little bit of COMM216, that phase cancellation is a timing issue that occurs as sound pressure is traveling at different times. And the typical manifestation of it that causes problems for us in professional audio is a reduction in lower frequencies. That's typically how it manifests itself. So using this type of technique can help mitigate that when in other methods, for instance, depending on the piano, depending on the space and the technique and types of mics used, we can help mitigate that using XY technique. This tends to increase the mid-range frequencies due to the cardioid pattern overlap. Again, we traditionally, again, conventionally use a cardioid condenser microphone for this, but you can use omnidirectional microphones. You can use different diaphragm size microphones too. In class, we would have used smaller diaphragm microphones to illustrate this, but you could use medium diaphragm microphones as well. But based on the amplitude of the piano, you don't really have a problem with saturation or amplitude levels that are so large that you need a medium or large size diaphragm microphone like a kick drum. So you can use a smaller diaphragm mic that accepts frequencies as low as the ones that we usually use in class are about 40 hertz. So let me pull up a video and we'll take a look here for a minute. Let me see if I can make this go full. There we go. So this is from Full Sail University in Florida. This was a good video that I could access, and this is what we kind of would have done. So if you look up here, you can see we have two microphones placed in this sort of XY axis, here and here, XY. And one of the microphones is aimed more at the lower frequencies of the piano, and this microphone is aimed at the higher, mid and higher frequencies. And I'm just going to hit play here. I turn the sound down for a minute. And you can see this is the teacher who was giving this lesson. Here we go. You can see, I'll just pause it, that we have this XY pattern that covers most of the piano's sound that is coming out of the piano, and most of the sound will be captured by these microphones with not too much room reflection, although they did mount these kind of high. This is called XY stereo or coincidental miking. Because the microphone elements are right next to each other, even though they're pointed in different directions, the idea and premise is that sound arriving here will arrive at this capsule at the same time, therefore minimizing phase cancellation that can occur and diminish low frequencies. Again, centered over the piano is very conventional. You can take a look centered over the piano here. So she's going to play. We'll take a listen. There can be a little more accentuation on the middle frequencies. Let's take a listen. Oops. There we go. A little loose cable there. Okay. Now, we're going to jump to the next type, and I want you to notice the different, and I'll point it out, the different quality of sound that we actually get on the second method. And I don't want to bias your opinion, but in class, when we normally do this, when I take a vote of what students thought sounded better, XY or the second one, people tend in our class, even here too, to choose the second one. And there's a reason for that. So if we look at the second method, we have this A-B spaced pair is what it's called, or spaced pair. Again, we're using cardioid condenser microphones. In this video, you're going to see they're using a medium-sized diaphragm, a larger mic, but you can still use smaller diaphragm microphones. It's going to affect tonality. It depends on the microphone you choose. And again, we get into a big topic of choice with microphones, but in this class, we're really concerned with you understanding methods and techniques. So we don't want to get caught up in that right now. You want to understand the techniques. Spaced pair. So basically, spaced pair means an equal vertical position above the piano in 3-to-1 ratio typically. So let's stop there and just clarify what that means. So we're going to have two microphones that are spaced apart. We want them vertically at the same level of the piano. And again, when I move to the video, you'll see this. We want them vertically at the same level of the piano. The 3-to-1 ratio typically is very conventional ratio for spacing out your pair horizontally. And the ratio basically is a 3-to-1 in that. Imagine if you had your microphone suspended 12 inches above the piano, both microphones. You want them to be 36 inches apart horizontally, if you can picture that. If they're going to be closer to the strings of the piano, then you'd want them to be a little closer. And you would follow this 3-to-1 ratio. So if you have 12 inches above the strings, 36 inches apart, if you lowered the mics to 6 inches above the strings, you would divide the 36 and have 18 inches apart. This ratio is ideally what keeps the sound traveling to the microphones, it helps keep the stereo image intact. Now, you don't have as much of a stereo image as you do with XY with spaced pair. But the important thing is when you're using spaced pair, you want to try to minimize sound from entering one microphone faster than the other microphone. Ideally, you want to try to have them enter the microphone capsules at the same time. It's never like XY coincidental, so you want to be aware of that. The difference here, though, is if you look at the third line, we have a better capture of lower frequencies. But again, we might have some phase cancellation due to this, and we have to watch over a diminishment of low frequencies due to that. However, spaced pair can give a more frequency-specific capture to each mic, as you're going to see where the microphones are placed more specifically over sections of the piano. So when you had the XY, you saw how it was centered over the center of the piano. Let's pull up the video, and let's take a look. Let me turn the volume down for a minute. At spaced pair and what they're doing here, and I'll just talk over this. So what he set up was, there we go, 2 microphones. This one over here in the back by my cursor, that one is covering the low strings. This one's covering the mids and high frequencies. Notice that both of them are approximately the same height above the strings, which is important in this. And if they did this correctly, which I'm sure they did, the distance here is in a 3-to-1 ratio. So these are spaced 3 times farther apart than the height. So if this is 6 inches, let's say that's 6 inches. Then going this way horizontally, it's 18 inches. If this is 12 inches, it'd be these are going to be measured 36 inches apart. Now again, these are all conventions. It is very common, this engineer might put them closer together, might put them farther apart from experience and make decisions based on desiring a different tonality. Generally, again, conventionally, this works very well for most grand piano miking. We're going to take a listen too, and what I want you to notice, if you can compare, is the low frequencies on the bottom are a little rich, a little richer.
For this
now using this is a third technique we're not going to talk about in this class. It's called Bloom Line for anyone interested. I'm not going to have you cover that. Just A/B spaced pair and coincidental. Now, because we have this focusing of microphones over specific areas of the piano, when we go to the mixing board or Pro Tools and we play with the panning, we can create more of a stereo image, but we have more specialized frequency capture from each microphone because they're spaced out. We have one microphone covering specifically the high frequencies and mids, and one microphone covering specifically the low frequencies. So again, both of these techniques are useful. Both techniques are useful and used for the decision to use one over the other comes with experience, of course. You're not going to have to do that, obviously, where this is our final lecture. You need to understand this and be able to reiterate this with some test questions regarding this. Understanding these 2 techniques that are very common for miking piano. Again, we may use these techniques for an upright piano, and we do quite often. But these are 2 biggies regarding miking a piano. Now, in addition to those above methods we talked about, it's common to use an additional mic 4 to 6 feet away from the piano. What we're capturing now is the overall sound of the piano combined with the ambient tone of the room. So we may do a AB stereo, an XY coincidental or AB pair in stereo, but we may add a microphone for ambient reflection. That third microphone almost, when we do this, can act like a reverb channel. We're getting the sound of the room tone with the overall sound of the piano and the wood reflecting the strings from the design of the piano. So all 3 channels can really make a nice tone. Of course, this ambient tone has to be added carefully because it can make the piano sound much farther away, as reverb does. So we have to be very measured when we add this. That's an example of another method that may be utilized. If the mics are well placed, hopefully there's minimal equalization needed on a well-tuned, well-designed piano. And outside of this ambient microphone, you can also use instead reverb in a measured amount to add some dimension to the sound. So that's another factor when we're doing audio recording of a piano. And I wish we could, but obviously this is what we got. All right, so let's move on to the art of mastering. So what is mastering? Well, here's a little definition. It's the art of manipulating the final mix down of a recording to be reproduced for consumer playback. It's sort of the step between the engineer mixing and the final user listening, enjoying, broadcasting, what have you. There's a step in between. Now, mastering sometimes is not done, especially in when we look at things like news, broadcast television, things that are where audio unfortunately takes a bit of a compromise due to the speed it needs to get out into the market. Sometimes mastering is, or quite often, mastering is actually overlooked. Live television, there's generally speaking no mastering if it's live, just inherent of the nature of live TV. It's done right as the consumer consumes the audio and video, or just audio if it was radio. So there is no mastering step. But when we look at things like film, music, recording, we have this mastering step. And so it's something we want to visit here. Again, you're going to have to understand this. There's no lab on this, but it's something that you want to be able to show me that you have comprehended what this is. Let's move on to the next slide. Okay, so the idea of mastering is first take all the tracks, bounce them to a stereo track, and you've done that before with COMM216 and other experiences using audio in Pro Tools. So just bounce it down, then open a new session of Pro Tools and insert the stereo track. So you basically mix down. You're basically, this would be the stage after your third lab. So if you think about it this way, your third lab you're sending me in PTX form so I can grade it and evaluate it. Let's assume that I'm the mastering engineer and you are the mix engineer. You would mix it down just like your assignment. You would finish it, and then you would send it to me, just like you're doing. If I'm the mastering engineer, I would take your mix, everything you've done, mix it down I would bounce it down to a stereo track, or have you do it and send it to me once I approve it. And then I would enter this phase of the recording process. So what is this phase? Well, the first thing is I'd be checking the optimal volume of the song. Now remember, we only have 2 tracks now. Everything's mixed, automation's done, compression, that's all done on each track. Everything, it's done. So I want to make sure all the songs, if we're doing an album for an artist of 10 songs, we want to make sure that all the songs are calibrated the same. We don't want to have a listener download this album of music and have the first song be very loud, the second song very soft, and the third one be very loud, etc. We want to make sure there's a consistent volume, so an optimal volumes of songs in mastering. Second thing we might do here is a final stage of modest equalization adjustments where needed. You, as the mix engineer, have gone to each track and applied some degree of equalization if needed to compensate or to accentuate certain frequencies. Now everything's blended together. Everything sounds really nice, but it's very common that we need to add a little reduction or accentuation of some frequencies to get a final desired equalization curve that the producer wants for the listener. So the mastering engineer may do that. And again, they're just mixing a stereo version of it. So the third thing we want is additional dynamics control where needed, some compression. Now, for those who are really into this stuff, it's very common here we use something called multi-band compression. We're not going to go into that because it's a little advanced for this course. Not that anyone couldn't get it, but I don't want to give you more than you need. But multi-band compression is very commonly used here. But the basic thing you need to understand is that we may apply some additional compression containment for this master. We have all the tracks mixed down. We've applied compression, obviously, to the kick drum, snare, bass guitar, vocals. But we may need a very modest amount to smooth out this in a stereo form. And fourth, we have gap times. Gap times, which today is not, because of the amount of downloaded songs versus albums, although albums are still bought and downloaded. Gap times were a big deal in the let's say, going back before the we'll say before 2000. 1990s, 1980s, and so forth. When you had an album, it was the amount of space allocated between songs. When a song would end, how much space before the next song would start? Would it be 2 seconds, 4 seconds, 6 seconds, 5 seconds, a minute? But we still want to deal with gap times because you may, as a mastering engineer, want to build gap time into the actual track of when it starts and when it ends. And you can do that when you're doing your master in Pro Tools. You may want to add 1 or 2 seconds at the beginning before the track actually starts, and that's something you would do as well in mastering. So these 4 things are 4 conventional, typical things that would be done in mastering. When you're finished with that, you would then bounce it one more time, essentially, and that'd be your final product. That would be your product to go to be submitted to a digital, iTunes or Amazon's downloading service, or there's a lot more than those 2 big ones. Wherever you want to market your music, you may want to print a CD still, and you would send those files to the CD production house and for them to make CDs. You may want to distribute them on USB. In fact, there's companies that make specialized USB for sticks for artists to sell that have their logo and things like that. So after this stage, this is the final stage before it goes to the customer, essentially, and the customer then will hopefully enjoy the product. Again, your lab is only up to the mix stage. It's almost as if you're sending it to the mastering engineer. Sometimes mix and master engineers are the same people. Very, very common, especially smaller productions. So you'll have a mix engineer and also the master engineer be the same person. Sometimes the mix needs to go back and be readjusted. So it's common that you master something and you're just not happy and one little thing needs to be changed. So the mix engineer has to redo it and then send it again to the mastering engineer for adjustment. So it's pretty cool. It's pretty neat stuff, but nothing too crazy. So you want to make sure you understand that. Let's take a look now in Pro Tools at mastering. Let's actually do it now real quick. Let's actually go into Pro Tools, our project, and throw a master together so you can see it work. Here we go. Okay, so here's our mix of our song for the course, and we have everything in there, and I put a basic mix together here, got a couple things applied up here, and let's say I've gone through all this, and I put in my effects, and my, I've put in my equalization on all the channels and everything, and I finished essentially the lab, and everything's in. Like, this is from last week when we started the drums and snare. So everything's done, and we put automation into this, and it's all ready to go. So let's just play it. And let's pretend, it's fully done. Obviously, this I would still have to work on and apply my automation and everything that needs to get done before it gets sent over for mastering. But let's say it's done. Okay, so we have a little basic mix here we can utilize. Let's see if this is even. Good. Okay, so we have a little basic mix here. So let's say everything's put in. We would go over to, just like you've done before, bounce and disc. And we want to keep this in wave format. We do not want to ever compress this until it's ready for distribution to a final customer. Always keep it in the wave format. Again, MP3 is compressed, and you should remember that from COMM216, I hope. Interleaved, and by the way, just a reminder, interleaved means that we have a left and right mix. We can have multiple mono or a summed mix, which we wouldn't want. We want to keep this in true stereo form. 6-bit 4-1, okay, that's good. All right, so let's call this ready to master. And we will, I'll do this offline, we'll bounce it. So we'll bounce this real quick to a stereo track is what we're going to have. So when this finishes bouncing, let's take a look at, let's reinsert it into a fresh batch of Pro Tools. Okay, so here we are in a fresh session of Pro Tools here, and what I've done is I have simply imported the what I called ready to master file. And again, this is all of our 20 or so tracks, mixed, automated, etc., everything we did to it into almost consumer use form, but it is in a stereo form. So if we play this, it's mixed. It's not mastered yet, but it's mixed. Basically almost ready to go. Now again, some students have asked, can you just skip this process of mastering? Absolutely, you could. Sometimes it's done due to time or budget. For large, high budget recordings, it's not. It's typically done because there's too much money at stake in the production. So we're now, we have a one stereo track. Let's go to mix here. One stereo track and one main master output. That's it. I can't, now the important thing is I can't change anything outside of these mastering techniques. That's it. It's mixed. If the vocal's too soft somewhere, we're stuck with it. We have to go back to the mix process and redo it. So what we would do in mastering, this is where a master engineer or the mix engineer would take a second listen and try to correct things in tonality of the song as a whole. All right. So first thing we'll do is throw an EQ in here. Okay, and we'll start making some modest, typically it's always school of thought, conventional, reduce unwanted frequencies versus boost frequencies you desire. So we're going to just take a quick listen and see if I can find some frequencies I don't like. Remember, everything comes down with it. If I lower, what we have, 6 kilohertz here, the entire song is bringing those frequencies down. Drums, voice, everything. Pretty bad. Wouldn't do that, just illustrating. But what I might want to do in this case, as I listen, I want to give a little shelf boost to the high frequencies. I want a little more clarity. Way too much, just a test. That's it, just a smidge. I'll get a little more clarity there. I might want to find a mid-frequency that sounds a little harsh and pull it down here. Not a lot of frequencies. I want to have a very high Q. Right about there. There's a bit of an art to this. Now, take a look here. Notice that my input and output of this is, I have some distortion going on here. So I got to also make sure these levels are correct. We don't want any signal distorting in or out of this equalizer. Just gonna make some adjustments here. All right. Good. All right, let's say I'm happy with that. Again, I'm doing this for illustration. So I'm not being super critical. I want to make sure you guys understand the methods more than actually doing the master. So let's jump into some dynamic control. And again, everything has compression. So we are listening for smoothing the song as a whole. So we don't want to apply too much compression at this point. If we start over compressing, we can really affect the tonal quality of the whole song. There we go. All right, let's take a listen here. Notice it's a stereo compressor too I'm using because I have a stereo track here. That's the way it is. Chill out, what you yelling for? Lay back, it's all been done before. Now if I over compress this, you can really lose some high frequencies as well. And you can lose some, everything sounds too squashed is the term we tend to use. Everything sounds kind of lost its energy because I've just over compressed it where the threshold is. So. Good. Little over compressed on the kick drum still. I'm actually not happy with the kick drum. I would actually want to spend some time in my mix before I got to the stage. But again, I'm doing this as an illustration. But I would want to rectify my drums first. But again, this is what this stage is what we would be doing. We would be listening as a whole and applying compression. As I said before, this is actually where we might use what's called multi-band compression, which is compressing only certain groups of frequencies. But you don't have to worry about that. You just need to understand that this is a modest application of compression to the song as a whole. Now, if we go back to the edit window and we talk about gap times, okay, so the song kind of starts right up, but let's say we have a strategic reason that we want this, 2 seconds of delay before the song starts. For some reason. Whoops, let me change this to time. And see, I may have done the wrong amount. Good. So let's say we like that time frame there, 2 seconds before the song starts. We want a gap time. We could do that, and of course we'd want to do a little bit of that because if you remember when we talked about this the other week, we want to make sure we don't hear any pops or clicks as the actual soundtrack gets implemented in the track. So let's play it. Good. So we've just added 2 seconds of gap time right here. And we may want to also, very common in mastering, more in the 1980s. The 90s sort of phased out of this, even though it does occur. From the 1980s and beyond that, or before that, the 1970s, it was very common for music to fade out. Sort of like the song goes on infinitely and would fade out. And mastering would do this too. So if we had a situation like that, this song, kind of typical pop song, just ends. Right? We might do a volume fade out here, which we can do using this tool, even though typically you wouldn't want to. That's not what it's intended for. But we might do a fade out instead, and mastering would do that. Now, I would typically do that with automation. I'm just illustrating quickly here. But in the mastering process, that's where they might do these fade-outs. Again, very common in songs, the early 1990s and before that. It was very common for songs to have fade-outs. It's almost as the song just played on infinitely forever. Today, we tend to write songs, record songs that just have a clear, defined ending, as does this one. But mastering is where they would do those fade-outs, right here. It can be done in mix too, but typically mastering is where it would be done. So then we would take this and do the final stage. We'd bounce it one more time, bounce it to disk, and we'll call this, let's say we call this Final Master, and maybe the song title, Complicated. Oops. Okay. And we will bounce this down to waveform again, not compressed. We won't do it because compression does actually diminish sonic quality. So we don't want to compress to MP3, even though it's hard to notice to most people's ears. It is a compressed file, which means there's some degradation to the quality. So I want to make sure it's in waveform at this point. And we'll bounce that down. There it goes. Okay, so then obviously I can bring up a media player. And just like any consumer would use, we can play the song. We have the 2 seconds of delay. And it comes in, and that's it. Product done. And now any person can enjoy our work. Or this is how your customer would obviously take it. Done. There's your song. Pretty cool. And it's really cool, you know, when you do a production, or for yourself or for another person, and you do play it in this format, even though it's the same sonically as your master that you're working in, having it in the final stage, there's something that may be completely sort of psychosomatic, subliminal, that it seems to just come together in this form, even though it's technically identical to your master stage when you play it in Pro Tools. When you play it in this form, it just comes together. It's its own song. It's the way it was meant to be. It's all been done before. And if you... Now, one thing I will say before we bid farewell is it's very common in this industry, especially those listening to this lecture, to continually go back and remix and remix and remix and never be satisfied. If you're one of those people, you are not alone. Most people in this field never get satisfied. George Lucas from Star Wars was asked if he can ever watch Star Wars and enjoy it the way millions and millions of people enjoy Star Wars on the world, and he said no, he can't. He does not see it the way we see it. He sees errors, mistakes, etc. You'll have the same situation, unfortunately. At some point, you will have to accept what you have created, and other people will probably find no flaws in your work, where you will, unfortunately, as the creator, always find some flaws. So a little parting wisdom. Try to find that point you can sign off on your project and be proud of it. Okay, so that concludes all of your lectures for this course. I hope that you all were able to benefit from these lectures I did online, as it was our only real option. And I hope you are still were able to enjoy the course. And we did cover most of the topics, although truncated a bit this way. Going forward this week, assuming you're listening to this on Tuesday or Wednesday of this week, if you have any last questions, any problems with your lab 3 that you're working on, or test questions, please email me. If we need to set up a Zoom session, I'll be happy to do that. I do need a day notice because I'm slotting students in, but don't hesitate to ask me if you need any help, because during this week I am here to help you prepare for your final test or answer lab-related questions. I won't be available Sunday or Saturday, so if you leave it to Sunday night, you're on your own. If you leave it to Saturday, most of that day, I do have some other commitments right now. So please, through Friday, you have to reach me. If you need to set up a Zoom session, I'll be happy to. Outside of that, good luck with your lab creation, your final lab, and preparing for your final test again on Monday. And that is it for your lectures. I hope you all have a great week. Stay safe and healthy, and we will talk soon.